Welcome everyone, and thank you MPEX for allowing me to be part of this conference again. So I was here at the last one in New York in 2019, and I'm hoping to give a nice introduction to Elixir machine learning. You can find me online at A_forward, the various spellings of it, and today the code is available on GitHub under MPEX recommend. It's set up into two live view Phoenix projects and then a bunch of notebooks. I'm going to try and do some live coding. I do need to switch up the thing here, so if my fingers aren't working, I might just go through the slide presentations. So I was torn on how to structure the talk. When I started working with Elixir ML, I was actually new to the ML space in general. So I had zero experience with Python libraries, and I barely looked at TensorFlow years and years ago. So I thought, well, I know Elixir, so it can't be that hard. But actually, the lacking foundation was a huge problem. And so I'm going to position this talk more as an introduction to integrating machine learning into your application. We are going to talk a little bit of fundamentals of ML. And there's going to be two systems. So the title was recommender system, but I actually want to walk through a linear regression model, something that maybe we can wrap our heads around a little bit more, because I'm not going to be getting into the math on the cold start classification. If there are ML people in the audience, then I'm asking forgiveness, not permission. So it should be seen as a newcomer's view to machine learning and Elixir. And much like the Phoenix view of falling into the pit of success, my missteps are more an opportunity for the Elixir ML community to make it easier for me not to make those mistakes. So enter GiftBetter. It's an auto-based startup. They offer white glove services so their teams can get highly customized gifts. These can be for their employees, prospects, clients, or even special events like this one. They've got several years worth of data on gift giving in a very personalized manner, and I'm trying to help them scale their business through kind of automation and insights into their data. From GiftBetter, a gift is a highly curated set of items. So it could be a fancy locally sourced coffee, a French press, and maybe a branded mug, all from sustainably focused companies. These gifts are going to be purpose-built for their clients and kind of are given as onboarding, retention, appreciation, things like that. So part of this path to scaling is how can we make better inferences about their data? And this is going to range from curating gifts, so how can their team help to better curate their gifts based off the types of gifts they've given in the past? And how can they get this into more of a self-serve so they can start to attract smaller companies to come and use their services? It's a great gift case study in kind of a no-code solution. So they went out there and they built a thriving business using semi-structured data from Google, Shopify, their other CRMs, things like that. And I'm trying to move that into more of a structured world. So, this data fits kind of nicely into a very boring Elixir application that runs Elixir Phoenix and LiveView and is backed by Postgres. And we're right now deploying it to Fly.io. I'm at an Elixir conference, so maybe you don't think this is an absurd question to ask about, why am I trying to build machine learning that isn't in Python? And again, if you read any book on it, it's the de facto, and they say, hey, we're going to use a programming language for machine learning, and yeah, it's Python, So I still hope the question is asked, and I'm going to answer it on a few fronts. So, first is that what I've described seems to fit into kind of a recommender system where they want to be able to recommend gifts both internally so they can help curate and externally to expand their client base. A lot of that comes down to data curation, right? A lot of it comes down to how you can extract and label the data. So Elixir through Ecto and Phoenix and LiveView, they provide excellent tools to manage the data, accessing APIs, and giving the GiftBetter team a web front end to help visualize, clean up, and manage their data. And so this is going to account for 50% or more of any machine learning work. So second, the gift-giving rules aren't actually that complicated. And our first approach wasn't going to be to use machine learning. And machine learning books do kind of tout maybe it's okay not to start with machine learning. So again, we were going to code this by hand, but then I found out about Elixir having ML tools in place. It's been about 2 years now since it came out with NX and Axon, and these are neural network like tools. And so if I could stay within the ecosystem of Elixir, then that'd have huge simplicity benefits. And I knew that when we were ready to tackle ML, at least I'd have a place to start. But then I also discovered a few months ago Scholar. So Scholar is a very new to the world of machine learning in Elixir, and it provides a much let's say simpler approach with more traditional machine learning that's been around for 60, 70 years. And so the MPEX call for talks was coming up, and so there I thought, you know what? I'm going to push forward the timeline for integrating some machine learning. I'm going to see what I can do with machine learning and Elixir. Scholar is a more traditional ML library. I'm not going to be touching on the fancy, cool new stuff of neural networks and large language models and that. Just note that if you're looking at that in the Elixir space, you've got Bumblebee as a great resource, as well as Axon, and there is a lot of availability for data sets and integrations and visualizations. All right. So what are we looking at here? We've got a scalar, right? So just a number or zero-dimensional array. We've got a vector, a matrix, a 3D array. We could have a 4D, 5D. In mathematical terms and in the ML space, we call this a tensor. And then just to gauge my understanding, I didn't know what this was even just a few months ago. So the tensor is a data structure that can be any of those. A number, so a scalar, vector, matrix, any kind of numerical array, and it is the basis for all of that machine learning mathematics. So now I'm going to try and switch out into my live book, and let's write some tensors in Elixir. All right, so we're using cutting edge Scholar, so that's for a little bit later on. But when it comes to NX, so we can create a tensor. We can create our tensor 42. It can be an array.
Could you please make it a little bit bigger?
Yeah. We can make it a vector. We can make it a two-dimensional matrix. I love the number 48. Sorry, it's on the brain. And here we go. Now, the interesting thing to note is you've got the S64, S not for string but for short, and then you see the dimensions of it. So it's 2 by 2. There's 2 rows, and then they each have 2 columns. They do need to be balanced, so it's not. You can't have different things. It is going to complain at you for that. So you do have balanced elements, and then from there you can do a bunch of things. So we could get our data, and we could split this into an X and a Y. So we can say, let's take our data and grab all the data, and a little confusing, but let's grab the first row, spit it out. Oh, sorry, 0 to 0. So there I just grabbed the first slice, and I could possibly also then grab the second slice like that. So again, 43, 42, and that's going to come in relevant later. Let's go back. So we've got all that. Awesome. But today we're talking about machine learning, so maybe we should give a definition, get a common understanding. So at the core, machine learning enables machines to learn automatically from data. And we're going to use that past experience to improve performance, make predictions without explicitly being coded. So you might think, well, I use data in my decision making in my traditional software development, so how is that any different? So in traditional programming, you concretely know how to get to the answer, And in machine learning, you can't really know what the answer should be. You might see a picture like this on the interwebs for grabbing as a common visualization. So again, traditional rules and data get your answers. Machine learning, its answers and data get you your rules. I want to build on that a little bit. So I'm just going to rename here data to inputs and answers to output. So we input into our program. Our rules are coded in. We get an output. For instance, we're a pizzeria joint, and we want to prepare at least 2 times plus 10 pizza doughs for the night. So if we had 15 reservations, then if the math is right, 2 times 15 and 10 is we should prepare 40 pizza doughs for our tiny pizzeria. Flip it on its head. When we look at it from a machine learning standpoint, we start with the database of past reservations, for example. That would be our input data. We know how many pizza doughs were consumed on any particular evenings. Those are our answers. We can fit that into our model, into rules, build our model, and then we get our output. So we code the rules directly to create the program in traditional, and then we train our system to learn within our model for machine learning. So let's go back to our pizzeria example. We're going to help them better predict how much dough they should prepare for tonight's dinner service. Here's some past data that they have. It's Monday, 15 reservations. How many pizza doughs should we make? So we need to think in terms of features, labels, and how we're going to fit the data, what kind of algorithm we're going to use. So in our problem, we're going to start simple. We're going to think about our reservations, we're going to think about our pizza doughs, and we're going to assume that it's a straight line. We're running a little bit short on time, so I'm going to pop through some of the live coding. We can graph this. This is graphed with Vega Lite, and it's available in the notebooks. And with a line, it's y equals mx plus b. We have our bluish dots that kind of show where the data is, and then the machine learning is going to graph that through to a line. So we want to answer our question, how many with our 15 reservations? If we draw a line, we see about 52. When it comes into looking at it from a Elixir standpoint, we're going to create 2 tensors, one which represents the rows of data, and that's our x. Our y is going to be all of the answers. It is just a vector. We throw it into our linear regression. We get our answers back. I just want to digest a little bit of some of the terminology that I've used, or maybe haven't used and should now start to use. Our answers are called our labels. This is the variable we're trying to predict. In this case, it's how many pizza doughs to create. And it's also typically represented by y. Labels can be yes, no. For instance, do I recommend the skipped or not? Categorical, is this a cat, a dog, or a pony? Or in this case, the continuum for our pizza dough example. The inputs are called our features, and that describes those input parameters. We just picked very simply a number of reservations, but you could also include in here days of the week, months of the year, is it a holiday, what are the weather conditions, and this is where ML can really shine, is that you might be able to know how to get to the answer, but it's just so much, right, that you want to throw it into your algorithm to kind of do the work for you. Lastly, our output is more called an inference. So you're making a prediction not because you're guessing, but it's a prediction because there's a probability that you think you are right. Now, how we're going to do this within our Elixir application, right? ETL for machine learning is a huge pain, right? So that's where Elixir fits in really nicely with being able to extract, transform, and load that data. So let's go and run through how we might do this in Elixir. So first, we need to know that we are too busy on Fridays and Saturdays to take reservations, so we need to throw that data out. And then we want to track the reservations from our reservation system with our POS for the pizzas that were sold. So now we're just back into regular Elixir world. Nothing fancy about that. We're going to reject Friday and Saturday. We're going to align the 2 systems of POS with our reservations. Here's where we now throw it into our machine learning vector. We do need to split it. So here we actually see concretely that our features are rows of data. So it actually is a matrix, but our labels is just a vector. We're going to fit that into our linear regression, and now we get our answer. All this is available in the pizzeria application. So where's our pizzeria? Here we go. So yes, so for today, we expect 50 reservations, and that's based off of 136. If you're on your phones, no idea if it'll crash or not. Oh, shoot. Yes, thank you, thank you, thank you. Call it out next time. I need to also mirror. Perfect. All right. Yeah, so this is deployed at the free Fly.io instance, so this might not actually run. Yeah, you'll see here. Perfect. So this is what you get for $0. Fly.io still is great, but we haven't scaled it, so I do have the local one standing up. So the 50 reservations, and that's based off of the data that's in there. So we have this is actually based off of a year's worth of data, and there we have it. Let's hop back now. Okay, so we have this model. How did we integrate that into our application? So recall that our model is it's our program, right? Traditional, we code our program with ifs, else, blocks, loops. A model is a data structure representing the internal variables needed to run that model. So in NX, we can serialize. So we can serialize this to something we can then write to file. We can then actually compile it in. So we can, at compile time, compile it into our application, and then we can make our predictions, again, using the predict function that's available within the linear regression from Scholar. We're going to do a little bit of cleaning for formatting the answers. So, are we done? No. When we provide machine learning with enough historical data, we get to predict and fit and build a model. But that accuracy is going to depend on the amount of data, but it also is going to depend on the algorithm used. Maybe linear regression wasn't the right algorithm to use, so we're going to tweak the algorithm. Within tweaking the algorithm, we can also change things known as hyperparameters. We're not going to get into that today, but just note that there are your data, and there's also data about the algorithm you're choosing. This is all going to be to build our prediction model. Then we're going to make some predictions, and we're going to say how good was it, and we're going to rinse and repeat. So when we hear about underfitting just isn't about having not enough data. It's about having not enough of the good stuff. So not the right algorithm, not the right tweaked hyperparameters, but also not the right data. So we had 1 week's worth of data. We actually seeded it with a year's worth from our example, and it turns out that it wasn't very good, so we can go back and revisit that. For completeness, overfitting isn't necessarily the opposite of underfitting, and you can actually be overfit and underfit. You can think of overfitting as an over-reliance on memorization. So you actually trust too much of your test data, and that comes down to too much noise. So you can definitely rely on too much noise, but also not have enough of the good stuff. So how we deal with this is we need to have our training data and our test data split out, both from the labeled. From there, then, we train against the training data. We're going to evaluate against the test data. And how can we do that in Elixir? Well, outside of Scholar, just in NX directly, we can apply some loss or error functions. We have 30 minutes to learn all of machine learning, so I can't go too deep into this. But this is a loss function where we're just saying, on average, how off was I on each of those test predictions? So we can do our prediction based off of our test data. We're going to take off all the answers. Remember, the answers are called our labels. We're going to get the absolute value because we don't want the negatives to undo the positives, and we can take the mean. So we started with a week's worth of data. Now that we had our year's worth, we threw it in. It didn't quite work. We drew it into a polynomial curve, and we took our error from about 4 pizza doughs per night error down to 1.5. And there we have it. So that's our first integration of machine learning into an Elixir Phoenix web application. But today we want to talk about recommender systems. Everything we've done so far, we can still do in that. I just wanted to kind of ease into the recommender systems before throwing too much at you. So, recommender systems, it's a subset of machine learning. And we're going to use the data about users and items. So the items can be products, can be advertisements, can be articles that you want to give out. It's whatever you're trying to promote, and your users are those that are going to be interacting with it. So we're going to have data about the users and the items, and we want to determine how much a user might like or dislike a particular item. When it comes to choosing, we really have two main approaches, content filtering and collaboration filtering. Content filtering looks at the content. How similar are these user tastes to these item attributes? How similar are these items to each other? In collaborative filtering, it's more looking at the behavior. Is the behavior of this user like the behavior of that user? If so, then maybe we can suggest what the first person has done. So with content filtering, we can think about like, I like socks and coffee, and you might like t-shirts and tea. There's going to be relationships between the items. So if you like Weezer, maybe you'll also like Green Day. Again, from a collaboration filtering standpoint, it's more looking at the similarities. And there is a folklore kind of anecdote from the 90s about baby diapers and beers commonly being sold together. Even if that's not true, it still is a case of a behavioral characteristic for collaborative filtering. Very high level, very crude flow chart, but you can think, do you have information about your user? Yes. Is it behavioral information? Then you really want to try and look at collaborative-based user similarities. If you don't have information about your user, or you don't have good behavioral information, then you're going to start to comparing, right? You're going to compare items to items or users to items. With the comparison, if you're the first person to the site and we don't know anything about you, you don't have any history with that service, then we really need to look at the attributes of the user compared to the items, versus if you are comparing, I like the Weezer, so show me some other things that are like Weezer, then you can do the product similarities. As you're building out, you're definitely going to build a hybrid approach where if it is a cold start first user, you can do the user to item. As you start to get some behavioral information, you can move into doing the more collaborative or item based. At a high level, I've said similarity a lot of times. What does that mean? It means things that are close together should be liked or the same. Things that are far apart should be different or dissimilar or irrelevant. And these are available through the Elixir engine. Another application that is online but probably has already crashed. So the gifting platform is not open, and so I can't share any of that code. So I developed a very crude game tavern. So at this game tavern, you come in, you're going to sit down, play on your favorite console, your favorite game, have a few drinks, and I'm going to bait and switch that for today. Much of what we did with that first example, pizzeria, we need to think about what are my inputs, what are my outputs, and what model am I going to use. So from a simplicity standpoint, we're going to think about what is the cost associated with it. Is it a cheap game to play? And what's the type of the game? Maybe I'll recommend Pitfall, right? If you're coming in with lots of money and you can afford an expensive game and you still like that adventure, maybe we'll recommend the new Zelda for you. As for the algorithm, cut to the chase, we're using naive Bayes. Why? It's a relatively straightforward probabilistic algorithm, and it works really well with categorical data. So when we talk about these here, these aren't continuing like data, right? There is no similarity distance between like adventure versus sport versus what have you. So it works well there, but it also doesn't overly matter, because we want to get into that nice feedback loop pipeline where we're going to gather our data. It's going to take half the time. We're going to try and fit it to a model, make some predictions, see how well that prediction goes, and then we're going to tweak all of the things. Tweak our data, we're going to tweak our algorithm, and tweak our hyperparameters on that. So now we know our budgets, our features of budget and gameplay. We're going to look at the label, that's our output, that's the game to recommend, and we're going to use the naive Bayes classification. Few more things that we need to think about to do this comparison, and I'll show you how we're going to do that in Elixir. The first is we need to do this hot encoding. And so when it comes to these algorithms, you really want to have true or false for these options. One hot encoding would be like a truth table-like view, where each row you can only have one value being true, and the rest are zero. So this is known as one hot encoding. For simplicity, we're breaking it into 3 buckets: cheap, standard, and premium, and that's going to be based off of their database of how much it costs to rent that game by the hour. So if it's cheap, it's going to be 1, 0, 0. If it's standard, 0, 1, 0, and if it's premium, 0, 0, 1. So how do we do that in Elixir? We can use this equality call. And so here we're going to compare 3 scalar with our vector of 1, 3, 5, 7, 9. So that's going to produce out our 0, 1, 0, 0, 0. These are going to be now our features for our model. It's numerical Elixir, right? It's not binary or string Elixir. So all this code here is just to try and push strings into numbers. All the real magic happens in that equalities at the bottom, but we need to turn our sets into maps, turn our maps into lists, so we can one hot encode that information. Now, there's one hot encode and there's a many hot encode, but they call it multi. So for our gameplay, you can be both an action and a role playing, and this is where like the hot encoding works out nicely. Is that it's really the same code, just now we can be both action and role playing at the same time. So the hardest part is getting the data. If the app is still up and running and you're clicking on it, the recommendations were kind of hand-drawn by myself, so you might disagree with some of the outputs, but from that game tavern standpoint, they are tracking their labels for their games, they are tracking their features, in this case, the budget and the gameplay type, and now we're going to fit that into our code. So we're going to do that by concatenating the 2 features together. So we're going to tell NX, we're going to concatenate 2 together. I didn't see a one-hot or multi-hot encoding, so I just did T for, I can't remember what the T stood for, but transformations or maybe training. But that T is not part of the community. It's code that I've written within the open source that I've project for this talk. We're going to one-hot encode the budgets. We're going to want multi-hot encode the game types. And that's going to make us a big, long list of 100 or so features to train against. The output is going to be the games. In this case, we can do categorical. So we can do 1 to n categories for that output. We're going to fit it into our naive Bayes. We're going to use the complement algorithm, and the code is identical whether I picked any of the naive Bayes ones. For a classification problem, it's your inputs X, it's your outputs Y, and we just need to also tell it how many classifications are there. So we train it with this code. We predict it with pretty much the identical code. We now just only have one set of features to put in, and it's going to predict back out. The main part is the prediction. The rest is to clean it up, to put it back from a number like 17 into pitfall. If we wanted to get the top n, right, so if we wanted to actually see how can we get the top 3 predictions or the top 5 predictions for this, then we can actually get the predict probability. This is directly within Scholar, and the rest of that code there, that is to, again, grab the highest probabilities and then to map it back against 17 being Pitfall, 18 being Frogger, and so on. When we split out our training from our model, we might not know which naive Bayes we used, or even if we used naive Bayes, maybe we used KNearestNeighbours. So using Elixir, we can actually say, well, we know the model has a function called predict or predict probability. So we can actually just use the apply from Erlang to apply the model struct to get the prediction. So now it's a complete separation. So the people that are training your model could then change it without you overly being aware. So you're a little less coupled to the actual model that's being used. You rather just know this is going to be a classification model. Perfect. I think I got us almost back on time. Sorry I didn't get to do any of the live coding to run that through, but our quest is complete. When it comes to GIF Better, we're working on a release for our recommender system. It should be in a few weeks. One of the main developers decided to go to a conference in New York and needed to prepare fake data for the conference, so they had to be behind. And we're in the refining stage there. So it was a question, and what is the verdict? Do I recommend Elixir for a recommender system? And it depends. But no, there's two positives and one negative. So Elixir is great for web development, and it's great for getting structured data into the hands of the GIF Better folks. Livebook makes machine learning examples super approachable, and it's a nice way to document that. So when I'm onboarding new people onto the team, they can go through that. If you are looking for a transferable skill, if you are looking to get into the ML space outside of Elixir, then Python is really the route to go, because as much as you wish the language was agnostic in hiring, they probably will choose someone with Python library experience over Elixir. But if you are able to stay within the Elixir world, then so far my experience has been quite good. All right, I'm going to end it there. There's more slides, but we're already 7 minutes into break time. And I will take questions, but if they're poignant questions, maybe approach me afterwards.